Hey, 42 here. Human beings have adapted the world around us to suit our needs. It is our intelligence that allowed us to learn tool building, agriculture and language, and so become far more advanced than any of our fellow creatures. But that's not to say that some animals don't have wonderful abilities and tricks up their sleeves that we can only begin to marvel at. Thanks to the work of medical science and nutrition, we are living longer and longer, with life expectancy increasing by 1 year every 5 years. We are able to survive some pretty extreme places on Earth. But we have nothing on a little guy called a tardigrade, also known as water bears, or the super cute name, moss piglets. These segmented microanimals are typically 0.5 millimeters in length, and can be found in virtually every environment in the world. Their ability to survive is, to be honest, utterly ridiculous. They are the supermen of the animal kingdom, if Superman was a tiny 8-legged bear made of pillows. Think Canada is cold? Well, these bad boys can manage at minus 272 degrees Celsius. That's only 1 degree above absolute zero, where everything, right down to the atomic level, stops moving. Of course, they don't just put on a hat and get on with their shopping, they are in a state of cryptobiosis. That's like the deep hibernation that you see in sci-fi films. And they can only last at these levels for a few minutes, but bring the heat back up and they'll be out and about again getting up to mischief. If they fancy a bit of sun after a winter snooze, then you can crank it up all the way up to 150 degrees Celsius, and they'll still be knocking back the margaritas as though nothing has happened. They can take pressures 6 times what you'd find at the bottom of our deepest ocean, and can handle doses of ionizing radiation so high that just a fraction of a percent of it would turn us into dribbling mutants whilst our cells collapsed. They can even survive in space for almost 2 weeks, and can survive without food or water for over 30 years. They would probably prefer not to though. But if you want real immortality, then scientists are now looking at the scarlet jellyfish. Its gelatinous body may not offer much protection, but it has an incredible trick. If it does get injured, it sinks to the sea floor and returns to its juvenile state, called a polyp. From here, it regrows back to an adult jellyfish, with the slate wiped clean, effectively granting it biological immortality. The whole process takes about 2 months, so maybe one day, if you break a leg or two, you just have to pop back to kindergarten for a few semesters whilst you regenerate. It might help improve your terrible handwriting as well. When we think about light, we think about what we can see, but the visible spectrum is actually a very small part of a much wider range, and even within the visible spectrum, our ability to separate colours is actually quite limited. In the back of your eye, the retina, you process the light through cells called photoreceptors. There are 2 main types of these, rods and cones. The rods process just black and white, so they work very well in low light situations, and they make up most of your peripheral vision. You'll notice that you don't see much colour around the edges of your vision. You're doing it now, aren't you? You're trying to look out the side of your eyes. In the middle of your retina, where most of the light comes in, you have a higher concentration of cone cells. Cone cells process colour, and there are 3 types of them. One for long, medium and short wavelengths. This is all a colour basically is, a different wavelength. Long wavelengths are reds, medium are yellow and green, and short are blue. The mantis shrimp, however, has 12 different types of cone cells. If we had eyes like that, we would be able to see huge differences between every single shade of colour. It would make arguments over what colour to paint the bedroom last for a lifetime. It's bad enough that there's already a paint called elephant breath. Just imagine if there were 46 different shades of it. But oddly, shrimp's colour perception is actually not much better than our own, since they don't have the brain power to decipher all that information. Their amazing eyes just do most of the work, so their little brains don't have to. This is not the only quirk of their evolution though. Just like their cousin, the pistol shrimp, they can punch so rapidly with their claws that they have been known to smash aquarium glass. Finally, On vision, the pit viper may have slightly worse colour detection than we do, but they have evolved a brand new sensor pit between their eyes and their nostrils that allows them to see infrared light. This means that they can spot prey and be warned of predators no matter how dark it gets. The benefits of technology mean that we can enhance or replace many parts of our body, but these are all man-made. These kind of mechanics don't occur naturally, do they? Well, this is the Issus cleopatris. It's a small, plant-sucking bug, and it has evolved functioning mechanical gears. This allows it to jump extremely rapidly. It may only move at 5 meters per second, but it accelerates in under a millisecond at a force of over 500 Gs. To give you some context, 1 G is the normal gravity you feel on Earth. An astronaut leaving Earth experiences 3 Gs. So what is the point of these biological cogs? What purpose do they achieve? Well, the power comes from both legs, and at such an incredible rate that if there was a tiny difference between them, it would be impossible to control the direction. Imagine if astronauts were in a rocket with 2 engines and each were firing at different power levels. Houston, we have a problem. So to ensure that the Cleopatras aren't constantly crashing into walls, headbutting people in bars or accidentally committing suicide, the gears act to perfectly synchronize their leaps. The cogwheel turtle also has an obvious gear shape that has grown naturally, but this has no mechanical purpose. It just looks like he's listened to too much Marilyn Manson. Look at this guy. I know, where are his legs? They're completely invisible. Now, I know, our level of camouflage is pretty lame, but there are creatures out there that can change shape and colour in an almost magical sort of way. Firstly, there is the chameleon, of course, everyone's favourite hide-and-seek contestant. They can change colour and patterns in order to send messages, such as aggression or submission, as well as camouflage themselves. They sometimes use it as a way of controlling the heat they absorb too. How does it work? We used to think that they just had amazing control over the colour pigments in their skin, but it turns out to be far smarter than that. In the past couple of years, we have discovered that one of the layers of their skin is made up of a lattice of crystals called guanine. We all contain guanine, as it is a nitrogen-based compound that is one of the bases of DNA and RNA, so pretty important stuff. Chameleons can stretch this lattice layer so it reflects light differently. When the lattice is excited, it stretches, and this reflects longer wavelengths such as yellows, oranges, and reds. In a relaxed state, however, it reflects the shorter wavelengths, the blues and greens. Their skin also has a yellow pigment, which is why their base colour is often green, since the relaxed lattice gives off blues, and this mixes with the yellow pigment to create green. A far prettier colour-changing animal is the golden tortoise beetle. They look like jewellery most of the time, but not only is their metallic gold colouring pretty spectacular, they are very rare in the insect world as they can change colour. The layers of their shells contain nanogrooves that are normally filled with a light red liquid that gives them their golden shine. When this liquid is drained, the lower, darker red layers become visible, so when you watch them they turn from gold to red. This happens when they are agitated, and often during sex, just like us humans. But it's believed to have another benefit. Red-shelled bugs like ladybirds, or ladybugs in the US, aren't popular food for birds, so maybe the golden tortoise beetles are mimicking this to avoid being lunch. Even their gold colour could make them hard to spot, as the bright reflection would throw off their avian enemies. Now, colour is one thing, but the mimic octopus can transform its whole body to look like a wide range of other local creatures. It impersonates sea snakes and jellyfish, amongst other things, so that its predators avoid it. And it also uses impersonation to catch its own food, sometimes walking like a crab so that it can attract a mate and then pouncing on it before the crab realises it's too late. Aquatic Tinder is a scary place. Free for a drink tomorrow? Okay, but promise me you're not secretly an octopus. Opossums find the world in general a pretty scary place, which is why they are famous for thanatosis, or playing dead to you and me. But when real danger strikes, they have a nifty little trick up their scruffy little sleeves. Opossums can immunise themselves against toxins such as snake venom and plant stings. They produce a protein called the lethal toxin neutralising factor, LTNF for short. That does exactly what its name suggests: neutralises toxins. For snake bites, this means that they can counteract both the part that stops your heart and the hemorrhaging part which makes you keep on bleeding. For humans, the current way of dealing with a snake bite is through antivenoms. You have to take a sample of each specific snake's venom and then inject a small dose of it into another animal, such as a goat or a horse. Then we can extract a serum and use it to fight the poison when a human is bitten. This procedure is far from perfect, as you need to keep a wide range of different antivenoms, and often these days they're only kept at major hospitals. And I may be wrong, but you probably won't get attacked by a snake in a hospital. They're more of an outdoorsy type. So naturally, research into the opossum protein could be very valuable, as it's already been shown that mice can be injected with it and develop similar self-immunization skills to the opossum. A human-ready version may not be so far away. Let's just hope it doesn't make us all play dead too. The streets will be littered with people falling over every time a car horn sounds. Self-immunization is one thing, but our next creature takes it to a whole new level. This baby-faced little salamander is called the axolotl, and it has an astonishing ability to regenerate whole parts of its body again and again. Many other salamander types have some regeneration ability, such as their tails, but these guys can grow back whole legs, spines, and even parts of their brain. And there's not even any scarring, it's just like reloading from a save point in a video game. Lost your leg in a bike accident? No problem, just reboot. They're also over 1,000 times more resistant to cancer than mammals are, so they're a pretty healthy bunch. They also never smoke and only drink in moderation. There is actually a reason for their babyish face though. They are one of a few unique species that exhibit neoteny. This means that they don't go through a change to reach adulthood, or sexual maturity to be more precise. Most animals have a metamorphosis that changes their shape, colouring, and physical characteristics. A human adult isn't just an inflated baby. The proportions are all different. The head shrinks in comparison to the body, limbs lengthen, body hair grows, and so on. The same is true for most species. Just look at tadpoles becoming frogs, larvae becoming flies, and seahorses growing into full-sized horses. I'm not sure about that last one, actually. But the axolotl stays the same, it just gets larger. Most salamanders leave the water and grow fully developed lungs, but the axolotl stays in the water, and that pretty frill around its neck is its gills. They do have rudimentary lungs, but they don't really use them. Scientists have found that you can induce a change into adulthood in axolotls, where they become terrestrial salamanders. It's done by injecting iodine into their thyroid gland. Whereas us humans are forced to grow up by being sent to our rooms and not allowed to have any ice cream. What ability do you think ties all of these animals together? Any guesses? Are they super fast? Super smart? Do they look good in denim? Are they great at doing Sudoku? Give up? Well, their special skill is Electroreception. They have the ability to detect electrical fields and to use them as a sense, much like we use hearing and vision. It's almost exclusive to aquatic animals, since water, especially salt water, is a far better conductor than air. But bees do use electrical fields and charge in a very unique way. Plants are usually negatively charged, and bees can become very positively charged. We've seen them produce voltages of 450 volts during tests. This happens because they collide with dust particles and small molecules as they fly through the air. The collisions knock away electrons and leave positively charged particles stuck to the bee. Their waxy cuticles are very well insulated, meaning that they can build up a surprising amount of charge. This creates certain benefits. Firstly, they become stickier, since they attract the negatively charged pollen particles. But, incredibly, they also develop a communication with the plant. and we believe that they can read which flowers have recently been visited by other bees, due to the change in their electric field. It's basically floral advertising, so bees can bumble around looking in the shop windows to find out what they want without having to go into every store. And the electro bee magic doesn't end there. Uwe Gregers, a neurobiologist from the Free University of Berlin, has been studying the famous bee dance. We've known about their little waggle since the 1920s, but Gregers now thinks that the bees are actually creating a change in the electric field, which other bees read through their antenna. Right now, all we know is that they can do this. We don't know for sure if they really do. Their dance still remains a mystery. The platypus is part of a group of egg-laying mammals called monotremes, and they are the only creatures in the entire class known to electrolocate, aside from one species of dolphin. These weird little duck-faced otter monsters close their eyes and ears when they dive, and they use this electrical sense to detect the electric current produced in the muscles of its prey. This is why their heads sweep from side to side like a sensor. They also have ankle spurs that produce venom. When you combine it with their egg laying, it seems like someone got very confused when they were putting the platypus together and just grabbed whatever parts they could find. With all these amazing abilities, you might be sitting there feeling jealous of the animal kingdom and all its wonders. Why can't we jump like lightning, heal ourselves, and see in the dark? It's just not fair. So, to make yourself feel better, go play on your iPad, loudly, in front of your hamster, and tell him that he can't have a go because he's stupid. Thanks for the view, subscribe for more 42.